Hi everyone, let me hope you are all doing fine wherever you are. Once again, this is Erisa to take you through online math lectures. Today I'm going to teach you matrices, and this is going to be our third lesson in matrices. In the most previous lesson, that was the second lesson, we discussed addition and multiplication of matrices. Today we're going to pick up from multiplication of matrices, and then we bring in new things that maybe you have never heard of or you have heard of but they're not so clear to you. So let me hope you enjoy this. We say that if we are to multiply two matrices, then the number of columns in the first must be equal to the number of rows in the second matrix. And this is the compatibility test for multiplication of matrices. So if I had my matrix A, okay, of order 2 by 3, okay, then B must be a matrix, okay, of order 3 by whatever, maybe by 4, by 5, I don't mind. But what is important here is the number of columns in the first must be equal to the number of rows in the second. That's the most important thing here. And that's what we are calling the compatibility test or matrix multiplication. Let's see two or one more example, and then we move to something different. Let's look at this example. They are giving us two matrices. There is matrix A, which is having order 2 by 2. And there is matrix B, same order 2 by 2. So they are compatible because the number of columns is equal to number of rows in the second, therefore we can multiply. But the first thing they want you to do is to find A plus B squared. So how do we get A plus B squared? Let's first get A plus B in the first place. This is going to be 3, 1, 4, 2, okay, add it to 5, 1, 3, 4, okay, and you know we add the corresponding entries, okay, and what do? You get 3 added to 5, okay, 3 plus 5, then 1 adds to 1, 1 plus 1, the same thing happens down, 4 adds to 3, and the 2 adds to 4, okay. So A plus B, what do we get? We get 8, 2, 7, 6. Now we need the A plus B squared. Let's compute it on the next page. So we need to understand the meaning of A plus B squared, okay. A plus B squared means that A plus B is multiplying by itself, okay. So that's what we need, A plus B into A plus B. So what will be A plus B squared, okay, get 8, 2, 7, 6, and multiply by 8, 2, 7, 6. Remember, when we are multiplying matrices, we multiply row by column, okay. So what do we get here? 8 will multiply this row, multiply with this column to give us what we put here. Then the same row multiply with this other column to give us what we put here. Then down the same thing happens. Okay, so what do we do? Let me first erase this. Okay, so remember when you are multiplying matrices, okay, multiply row by column. We have 8 times 8 plus a 2, okay, times 7. Then you go to the next column and the first row next column, that is 8 by 2 plus 2 by 6, okay. Then down, do the same thing, 7 by 8, sorry about that, it is 7 by 8 plus 6 by 7. Then here I have 7 by 2 plus 6 by 6. So what's the product? That's what we need most. Okay. What's the product? 8 times 8 is 64. 64 plus 14. Get 64 and add on 14. That is 8. I think we get 78. So here we have 78. Then we move here. Okay. What is 8 by 2? 16. And 2 by 6 is 12. So 16 plus 12 is 28. Oh, sorry, let me change. This is not visible to a student. So let me use white. This is 28. So we have the entries on the first row. Then let's go to the second row of the product matrix. 7 by 8. Okay. What do you get when you multiply 7 by 8? So that will be a 56 plus 42. I think down we have a 98. Okay. Then 7 by 2 is 14. 14 plus 36. Okay. We get, I think the answer we get is going to be 50. Okay. This is 50. So we have a 50 here. And the product matrix is 78, 28, 98, and then a 50. Okay, that is a plus b squared. Now, next, what do they need? They want us to find a plus b. No, they want us to find a squared plus 2ab then plus b squared, which is the binomial expansion of a plus b squared. This is a perfect square. So we need matrix A squared, then we need matrix AB, and then we need B squared. So it's going to be a long way, but we have to be patient. You know, this is how we learn. So to begin with, let's compute A squared. Okay, A squared is 3. Or let me write a formula for it so you understand what I'm talking about. Is A multiplied by A. Get matrix A multiplied by itself. Do not attempt to square entries of A. That's wrong. Okay. So this is 3, 1 and 4, 2. Multiply by 3, 1. Same thing. Okay. Okay. Multiply by 3, 1, 4, 2. So as usual, we shall multiply row by column. Okay. I'm going to be super fast. 3 by 3 is a 9 plus 1 by 4, which is a 4. 3 by 1 is a 3 plus 1 by 2, that is a 2. 4 by 3 is 12 plus 2 by 4, which is 8. And then 4 by 1 is a 4 plus 2 times 2, which is a 4. Okay. So 9 plus 4, what do we end up with? 9 plus 4 is 13. 3 plus 2 is 5. 12 and 8 is 20. And then 16. So we have A squared is 13, 5, 20, and 16. Oh, there is a mistake in adding S, in getting S squared, and this is not supposed to be 16, but it is supposed to be 8. Okay. Next, we get AB, matrix A times matrix B. So AB, you get 3, 1, 4, 2, and we multiply it by 5, 1, 3, 4. Okay. So Let's try to be a bit fast since we have learned now how to multiply. 3 by 5 is 15 plus 1 by 3, which is a 3. 3 by 1 is a 3 plus 1 by 4 is a 4. Then we go to the next column, next row, the down arrow, and the first column, 4 by 5 is 20 plus 2 by 3, which is a 6. Okay, 4 by 1 is a 4 plus 2 by 4 is 8. So what is AB? Let's add. AB is 18, is 7, 26, and then 4 is 12. 4 plus 8 is 12. Now next we need B squared. B squared is B times B. Get matrix B and multiply by itself. B is 5, 1, 3, 4. Okay, so 5, 1, 3, 4 multiplied by 5, 1, 3, 4. Let's multiply. Okay, 5 times 5 is 25 plus 1 by 3 is 3. Then 5 by 1 is 5 plus 1 by 4, which is 4. First row, second column. Okay, then second row, first column. 3 by 5 is 15. Okay, I wrote it wrongly. So 3 by 5, I get the answer as 15. Plus, okay, 4 by 3, which is a 12. Then 3 by 3 is a 3 plus 16. Okay, yeah, 15 plus 12. So let's add. What do we get? We get A, which is 25 plus is 28. And then we have here 9. Then 15 and 12 is 27. And then 3 and 16 is 18. So A, B squared gives us, okay. Now we need A squared plus 2AB plus B squared. Remember, okay, this is going to be, let me shift it down. This is equal to A squared. We have the result. Let me get reminded of A squared first. So it's not about substituting what we have obtained before. This is the matrix we got for A squared. Then this is B, this is AB, but we are going to multiply it by 2. Then this is B squared, okay? Remember, when you're multiplying a matrix by a scalar, each entry has to multiply by that scalar. So this will multiply by 2, 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 okay? So here we have 13, 5, 20, 16, okay? 2 by 18 is 36. 2 by 7 is 14, okay? 2 by 6 is 52. Then 24. Then plus 28, 9, 27, and 18. So the task you have as a student, I will not simplify this fully for you, but now you have to find out what do we get if we add these three matrices, okay? Is the answer the same as what we got for A plus B squared? That's the question, okay? Try to find out as a student. You add, I'll not write the final answer for you. It's now your task to add 13 plus 36 plus 28. What do you get as a student? That is your work. 5 plus 14, okay, which is 19. 19 plus 9 is 28, which agrees with what we got before. So find out what you get. So just a small correction here. We had made a blunder in getting A squared. Instead of having 16, we are supposed to have 8. Okay, so you add and try to realize if A squared plus 2AB plus B squared is the same as A plus B squared. I think we are going to get the same answer, but try to do that as a student. The same thing will happen at this stage. We still made a blunder, okay? So This is supposed to be 8. How about this? Says if matrix A is 0, 3, 1 minus 2, okay, and S squared, okay, S squared is x minus 6 minus 2 and y, okay. The equation is find x and y. This is very simple. Let's do it super fast, okay. So S squared is A by A. And if you get matrix A, which is 0, 3, 1 minus 2, multiply by 0, 3, 1 minus 2, okay? Remember, we multiply row by column. 0 by 0 is 0, okay? 3 by 1 with a 3, okay? 0 by 3 is 0. 3 by 2 is minus 6, okay? Down we go to 1 by 0 is 0. 2 by 1 is minus 2, okay? And then 1 by 3 is 3. Negative 2 by negative 2 is a 4. So we have 3 plus 4, which is a 7. Okay. So what do we end up with? I've done this so fast because I believe you can now multiply. Okay. But they are saying that the given S squared is x minus 6 minus 2 and y. So what does this mean? That this must be exactly 3, negative 6, negative 2, and a 7. So from here you can tell what x is. X is 3, okay, and y equals to 7. And we are done. So we have done it so fast. Okay, why are we trying to now speed up? It is because you can now multiply matrices. Let's look at the next one. So I have given you this simple exercise. Okay, I call it simple because it is really simple to me. As a student, you may need to be just extra careful to get everything correct, but you try it out and see. The answers here are going to be interrelated. You will discover this as you do the exercise. Now, next, we discover and we discuss something so important, which we call identity matrix. Identity matrix. So let's discuss something important in matrices, and that is the identity matrix. Okay, sometimes it can be called unit, okay, matrix. Instead of identity matrix, you can call it unity matrix. Okay, so what is an identity matrix? If we are to understand an identity matrix, then there is something so important about square matrices that you have to understand. The diagonals of a square matrix. We have a leading diagonal and we have a secondary diagonal. So let's have some information. So at the ordinary level, when we discuss diagonal matrices or when we discuss diagonals of a matrix, we are basically going to be talking about a 2 by 2 matrix because as a square matrix like a 3 by 3, 4 by 4, it is really hard for an O-level student to understand. Much as the identity matrices, you know, you can write any identity matrix of any order, but when it comes to diagonals, we are going to restrict our discussion to the 2 by 2 square matrix. So if we have a 2 by 2 square matrix A, B, C, D with the entries A, B, C, D, then the entries here, okay, on this diagonal form what we call the leading diagonal. And then this other diagonal is called the secondary diagonal, okay? The secondary diagonal is this other diagonal in this direction. But why do we talk about leading diagonals? Here, when we're writing identity matrices, what is important is the leading diagonal, because an identity matrix is a square matrix with only one who's on the leading diagonals and the other elements are 0. Okay, so let's write something about this. Then we now deepen into the discussion about identity matrices. So a square matrix in which the elements of the leading or principal diagonal are 1 and the other elements are 0 is called the identity matrix. Then we are saying that any identity matrix of order n by n is denoted by I. So we are going to use capital I to denote any identity matrix, okay, of any order as long as it's a square matrix, okay. You know, identity matrices applies to square matrices. So if we want identity matrix of order 2 by 2, then it's going to be, let's write this. So an identity matrix of order 2 by 2 shall be written as I equals to 1, 0, 0, 1. We only have 1's on the leading diagonal. The rest of the elements are 0. So that's what we call an identity matrix, is a 2 by 2. Okay. Then we can also have an identity matrix of order 3 by 3. Okay. What you need to do is to observe one thing about identity matrices. First of all, they are square matrices. Okay. Second is that they only have 1's on the leading diagonal. The rest of the elements are 0. So you write 1, 0, 0. Then you write 0, 1, 0. And then 0, 0, 1. Okay. When you check so well here, you only have elements on this leading diagonal. You see 1 was only on the leading diagonal, and therefore is a 3 by 3 identity matrix. Okay, this is a 2 by 2 identity matrix. So we can write any identity matrix of any order, but we care less about higher orders and mind so much about a 2 by 2 identity matrix, because that's what is so important in our discussion. But there is also something you have to note about identity matrices, which is so important. Okay, if you multiply an identity matrix, okay, by the corresponding square matrix, the matrix will not change. It is unchanged. It just yields the same matrix. So let's write down something. This property of identity matrices is so important. Okay, any matrix times any identity matrix is the same as the identity matrix times any matrix, which is the same as that matrix. The matrix not change. Okay, so let's try to understand this. If A is a matrix which is 2, 3, 1, 4. Okay, this is a 2 by 2 matrix. Then A times I, you get 2, 3, 1, 4, and multiply by the identity matrix of order 2 by 2, which is 1, 0, 0, 1. Okay, you know what we do in matrix multiplication? Multiply row by column. Okay, this row is gonna multiply with this column. So we have 2 times 1 plus 3 times 0, which is a 0. So I have 1, okay, 1 times 1, then plus 4 times 0, which is a 0. Then I have 2 times 0, which is a 0, plus 3 times 1, which is a 3. Okay, then I will have 1 by 0 is a 0, plus 4 by 1, which is a 4. Okay, so what do we end up with? You will get this as 2, 3, 1, 4. So the matrix has not changed. Okay, therefore, that's why you call it an identity matrix. Multiplying an identity matrix by the corresponding, n by n order matrix, it does not change the matrix. It remains unchanged. Let's check the other way. This is A by I, okay? What about I times A? In matrices, the order of multiplication is so important. But when it comes to identity matrices, there is something so unique about, okay? The order in which you multiply does not matter. Let's see I times A. So I by A is 1 0 0 1 multiplied by 2 3, then 1 4. Okay, keep the order of multiplication. Multiply row by column. Okay, so what do you end up with? So here we're gonna get, okay, 1 times 2 is a 2, plus 0 times 1 is a 0, then 1 times 3 is a 3, plus 0 times 4 is 0, 0 times 2 is 0, plus 1 by 1 is a 1, then 0 times 3 is 0, plus 1 by 4 is a 4. So what do we get? We end up with a 2 3 1 4. So the matrix has not changed after it has been multiplied by an identity matrix. Okay, so what do we conclude? We conclude that A times an identity matrix is the same thing as identity matrix times A. Okay, and that gives us the matrix, which is A. And this property is really very important in matrices. We're gonna use it somewhere. So why care about identity matrices? Okay, why are we bringing the concept of an identity matrix? First of all, we are going to make use of this, okay, somewhere very soon. And then next, we shall start identity matrices can help us solve simultaneous equations. Why don't we get there? By the way, there is something you need to know about identity matrices. Let me take, for example, I squared, which you have discovered in matrices. It means I times I, and this is 1 0 0 1. Okay, in this case we are dealing with 2 by 2, so 1 0 0 1. Okay, if you multiply 1 times 1 is a 1, then plus 0 times is, so without wasting time, this is going to be 1 0 0 1. It produces an identity matrix. Okay, so there is something we can conclude here, that I squared is giving us the same thing. Okay, generally I to power n will never change. It remains I, provided n is an integer, okay, which is a positive integer. It is never change. It's like having 1 to power n is always 1. So even the identity matrices, I to power n always produces the identity matrix. Okay, now let's see an example here about identity matrices. So example. So let's talk about this example. It said that if matrix A is 1 1 xy, okay, this is matrix A, okay, and the S squared is an identity matrix, then they want us to find x and y. So what do we need to do? Let's first get S squared, that is A times A, then we compare it with an identity matrix. It will be very easy for us to solve for x and y. So the struggle is about basically getting S squared. Let's get it. Okay. 1 times 1 plus 1 times 1 plus 1 times x, which is x. Okay. Then we move. We have 1 times 1, that's 1, plus 1 times y, which is y. Then let's go the down a row. X times 1 is x, plus, okay, y times x, which is xy. Then we have x times 1 is x plus x times y, that is xy. Okay. Oh no, there is a problem here. There's a very big problem. Let's revise this. Down a row. Okay, we have x times x is x, then y times y is y squared, so this is plus y squared. Okay, but life is simple. They are saying that S squared is an identity matrix. Therefore, this must be 1, 0, 0, 1, which is the identity matrix. Now, next, what do we do? Okay, let's try to compare, corresponding elements. Two matrices can only be equal if the corresponding entries are the same. So what does this mean? This means that 1 plus this element here. Okay, let me change the color. This element must be 1 and this element must be 0. Okay, so we have 1 plus x must be equal to 1, meaning that my x is equal to 1 minus 1, which is equal to 0. Okay, what I do, I take this the other side, and 1 minus 1, that is 0. Okay, then I also have 1 plus y is equal to 0. So what does it mean? This means that 1 minus 1 plus y is equal to 0 minus 1, and therefore y equals -1. Okay, you will get exactly the same thing by dealing with the lower entries, but here it is gonna be x plus xy is equal to 0, or you can say x into 1 plus y equals to 0. And in mathematics, when you have a product of 2 and is equal to 0, even if they are n, okay, it will mean that x is equal to 0 or 1 plus y equals to 0, meaning that okay, y is equal to -1. Okay, but you also have this other part which says x plus y squared is equal to 1. X is 0. Okay, then y squared is equal to 1, and therefore y has a possibility also of being positive or -1. Okay, but in this case we have seen the y value which works is y is equal to 1, because it's the one which you are getting from the other three solutions. Therefore, you discard the positive one, and it's not really a good idea at this stage for you to use this approach, because it's just simple. From the first three, you can just equate and have the value, and that is it. Don't complicate your life. Okay, therefore x is equal to 0, y is equal to -1. You have solved it. Very simple. So we now know the meaning of an identity matrix. Okay, it will be used in the coming discussion. But before we make use of the identity matrix, why don't we go ahead and discuss what we call the determinant of a matrix? So when we talk about determinant of a matrix, what should come to your mind is a square matrix. And at this level, okay, remember this content is targeting ordinary level students. At the O level, we shall only discuss determinant of 2 by 2 square matrices. Okay, other higher order square matrices like 3 by 3, 4 by 4 are discussed at the next level. So what do we know, or what do we need to discuss the determinant of the square matrix? You have to know about the leading diagonal, okay, or the principal diagonal. Sometimes it's called the major diagonal, okay, and the other diagonal, which we call the minor or the secondary diagonal. So this other diagonal, which is not really well highlighted here, is what we call the secondary diagonal or the minor diagonal. Okay, so why are we talking about leading and the secondary diagonal? You know, when we compute the determinant of a square matrix, we take the product of the leading diagonal, okay, and less the product of the secondary diagonal. So that's why we are introducing these two diagonals, so you get to understand before we now start talking about the determinant. So why don't we talk about determinant then? So determinant of a square matrix equals product of elements in leading diagonal minus the product of elements in the secondary diagonal. So we shall use this symbol, okay, for determinant. It is a rectangle. It is used as a symbol for determinant. If you don't want to write the word determinant, you can just write, rectangle. We shall know that that means determinant of a matrix, okay, as long as it is in the context of matrices. So it is the product of elements in the leading diagonal minus product of elements in the minor diagonal. For example, with the A, if I want the determinant of that matrix A, okay, yeah, the abbreviation is allowed. But if you are using the abbreviation, then this is not correct. So what you should write is write in lowercase letters determinant of A equals to the product, which is A times D minus B times C, product of the leading diagonal minus product of the secondary diagonal. It's just something very simple. So there are some matrices here which we can try to work out. Since at this level we are dealing with the 2 by 2 square matrices, getting a determinant is really not a problem. It's just something very simple. And why do we care about determinants? You will discover in the coming discussion. But before you discover why we care so much about determinants, we need to know how to get the determinant of a matrix. And that's what I'm teaching you. This is very simple. Remember, you are getting this lesson online. Online, being new in my country, Uganda, and the neighboring countries, Kenya and Tanzania, it gives students some challenges. But like copying notes, the teacher will tell you in class, copy this, do this. But here you pause, put down what you want, because this lesson is going to be on YouTube. Yes, that's true. You are not going to be able to download it. Maybe if I give you permission, you can download my lessons, but you always take notes. This is a classroom kind of setting. The only problem is you can't physically see the teacher, but learning can happen. Okay, you only need to change your attitude. Now, something important I need to put down for you about the determinants before we start looking at examples is, let me write it down for you. So the first thing that we are highlighting is to get determinant of a 2 by 2 matrix. It is a product of elements on the leading diagonal minus product of elements on the secondary diagonal. Then something which is important is only square matrices have determinants. What do we mean? Okay, if you have A, B, C, D, E, F, okay, is a 2 by 3 matrix. Okay, this implies no determinant. Why? Okay, why are we saying no determinant? Okay, at this level, we are going to say no determinant because it is not a square matrix. Remember, a square matrix, the rows and the columns are equal. Okay, but we don't want to go so much into this. What you have to know is that only square matrices have determinants. Okay, so examples. Let me just shower you with this simple example. It says find, okay, the value of x if 2, 1, 3x, okay, has determinant. Let me write this here. so we don't waste time. Okay, has determinant 5. Okay, so what we need to come up with in our solution is something very simple. Get the determinant of this matrix. Determinant, okay, determinant will be equal to product, which is 2 times x is 2x minus 3 times 1 is 3, and that must be equal to 5. Okay, we get the product of the leading diagonal here minus the product of the minor diagonal here. Okay, so that we have 2x minus 5 and 2x minus 3, and that is equal to 5. So next, if you have 2x minus 3, to take this negative 3 the other side, you have to add, will be equal to 5 plus 3. Okay, and then 2x will be equal to 8, meaning that my x is 8 divided by 2, which is equal to 4. Therefore, x is equal to 4. We have solved for x using the concept of determinants. Okay, just a few more examples. I give you an exercise and we stop here today. You know, online lesson, you should not go beyond the 40 minutes. It's not easy for a student to sit in one place for 40 minutes trying to attend an online lesson. And remember, this consumes data. So many of you are using what we call MBs, because if you have Wi-Fi, that is okay. Okay, yeah. So if you're using MBs, it's gonna take about 56 of your MBs. But education is not for free. Education has got value, and how do we start? Education has value? We pay for it. Okay, so if you want to learn something, you have to invest, and what you invest in is the money you give to a mobile or telephone company to give you MBs, or if you have Wi-Fi or whatever, as long as you are accessing the information. Okay, this is the value of education. Do not underestimate education, my friends. So they are giving us this information, okay, this exercise, and they want us to find the determinant of each of the following matrices. Now, as a teacher, I'll only do one for you, okay? And let me do the last one, solution. Okay? We know that the determinant of the matrix, okay? Determinant, to simplify my life, this is what I should do. Mathematicians come up with various methods. I'll let P, matrices are represented by capital letters. Let P be -4, -2, 3, and -4. Okay. Then I'll say determinant of P, okay, will be equal to a -4 into a -4 minus a 3 into a -2. And you have to be careful when you're multiplying a negative and a negative, end up with a positive 16. So this is a -3 -2 plus a 6, which is equal to 22. So the determinant of this matrix is 22. Now the rest are yours. Okay, so matrices, I thought I would teach it in 5 lessons, but I'm seeing, okay, in 4 lessons, but I'm seeing I end up with 5 lessons, because after this we have to look at the inverse of a 2 by 2 matrix, and after inverse of a 2 by 2 matrix, we can now solve some simultaneous equation. Is another application of matrices. Then generally we look at some problems about matrices. In the last lesson I will be discussing general problems about matrices that have been assessed in the past by Uganda National Examination Board, by the Kenya National Examination Board. I will be, trying to combine, since I'm trying to address problems of students in the whole of East Africa. With those few remarks, ladies and gentlemen, I am happy, you know, having you learning mathematics online from my channel. It is a difficult time, you know, most of us at home because of this pandemic, but I pray the Almighty Lord give you good health so we can continue interacting. I'll also tell you to subscribe to my channel and click on the notification bell. That way, if I upload a new lesson, you always get notified instantly. I also try to urge you to help me and share this, you know, the link I'll be sending you. You share it with your friends so I have more views, you know. That's how I also try to get something. Thank you so much, and I wish you a very lucky day, a nice day. Okay, stay safe. Bye bye.